Lesson 13.3, we're going to be talking about trigonometric functions of general angles. As well, we'll talk about quadrantal angles and reference angles. Those will all tie a lot of these ideas about trigonometry and about measuring angles and how angles relate to each other. That'll tie all these ideas together. Now, first we're going to be talking about trigonometric functions with theta in standard position. Now, theta, this Greek symbol here, is kind of the normal variable that you'll see used for angles. The measure of a given angle is what we would call theta. So in this case, if we have theta be an angle given in standard position, and the point xy is a point on the terminal side of theta, so we would say over here is our point P, and it's at xy in the coordinate plane. Our vertex was here. Our initial side is along that x-axis. Our terminal side goes right out through our point. So we would say that theta, our given angle, is in the standard position. Well, we can use the Pythagorean theorem to find the distance r from the origin to P. So what we're saying is, if we want to get to that point, we can use the Pythagorean theorem with our x and y to find what this length is, this length of r. Once we know what r is, we can find the trigonometric functions of that angle. We would say that sine of theta is y over r, cosine of theta is x over r, and so on. This table will kind of will show you exactly what each of the 6 trigonometric functions is once you know your r value. So let's take a look at an example of how this works. Obviously, the first thing we need to do is find where the point is. So if we're looking for the 6 trigonometric functions of theta, if the terminal side of theta contains the point 8, negative 15, so 8 is our x coordinate, so we go across 8 to about, say, here. Negative 15, I'm going to say, is about there, so our point is here. We'd say that's at the point 8, negative 15. Now, if we want to find, say, our initial side is here, vertex right at the origin, terminal side goes right through that point. So our angle comes all the way around, and we call it angle theta. And we want to find the 6 trigonometric functions. Well, again, like I said, first things first, we have to find r. So using Pythagorean theorem, we'd say 8 squared plus negative 15 squared equals r squared, and 8 squared plus negative 15 squared comes out to 289, in which case we can say, so r equals 17. From here to here, we know is 17 units long. Give us a little more room to work here. We can say then that the sine of theta, going back to our table, the sine of theta is going to be y over r. Our y is negative 15. Our r is 17. Similarly, cosine theta is going to be x over r. X is 8. R is 17. Tangent of theta is going to be y over x. So it's going to be the negative 15 over 8. So those are our 3 basic trigonometric functions. Remember, their inverses then. The flip of sine is going to be the cosecant. So the cosecant of theta, we can either just say is r over y, or we just know that it's going to be the reverse of sine, or the reciprocal of sine, so it would be 17 over negative 15. Similarly, cosine, the inverse then is secant, in which case we take the reciprocal and find that it's 17 over 8. And the inverse of tangent is cotangent. So again, flip those around and we have 8 over negative 15. So here are our 6 trigonometric values, or our 6 trig functions of theta. So if we wanted to find just 3 trigonometric functions of theta, if the terminal side of theta contains the point 5, negative 12, well, 5 would be about there, positive x, negative 12. So it looks like this is where our point's going to be. Our vertex is right at the origin. Initial side, terminal side goes right through the point. So here is our given theta. That's our angle again. It'll look really similar to what we had last time. We need to use the Pythagorean theorem to find r. So 5 squared plus negative 12 squared equals r squared. And 5 squared plus negative 12 squared is going to come out to 169. So, r equals 13. So using the fact that r equals 13, I'm going to do sine of theta, cosine of theta, and tangent of theta. And we can just plug things right in. Remember, sine was y over r, so it would be negative 12 over 13. Cosine was r, or x over r, so it would be 5 over 13. Tangent was x over y, so it would be 5 over negative 12. And again, if we wanted to find our inverse trig functions of each of these, it would just be the reciprocal. So it's literally that fast, that easy. Quadrantal angles. A quadrantal angle is an angle whose terminal side lies on the coordinate axis. So basically, any time where your the terminal side, your end point, is going to be right on the x or the y axis, that would be called quadrantal. So, looks like there are essentially only 4. If your terminal lies right on the positive x, positive y, negative x, or negative y. Those are the 4 main basic quadrantal angles. Because of the coterminal part of that, though, there's technically an infinite amount, because we can say either that this is 0, or 0 degrees or 0 radians, but it's also 360, or it would be 270. So 0, 360, or 720 degrees, all of those count as quadrantal angles, because they land right back onto the axes there. So list 3 quadrantal angles in both radian and degree. Well, that's pretty simple. It's just these pieces right here. So you can either say the 0 degrees and 0 radians, or I'll say 0 degrees, 0 radians, or you can say 90 degrees, pi over 2 radians, or you can say 180 degrees, pi radians, 270 degrees, 3 pi over 2 radians. Any of those would work. So this is more just a vocab word. Quadrantal angles are the ones that land right on the axes. So if we wanted to find the exact values of the 6 trigonometric functions of theta in standard position that measures 180. This is going back to talking about finding our trig functions of these values. So we want it in standard position. It's going to be a quadrantal angle at 180. So we'd say it'd come in this direction here. So our theta equals 180. In which case, because it goes right across the, or our terminal side comes right across the negative x direction, we can put a point there and say anything we want. I'm going to keep it easy and just say that it's negative 1, 0. This could be any x value here. We could say negative 12 or negative 72, negative pi if we wanted. The y value, though, has to be 0 because it's on that negative x axes. So if we have a point there, and we want to find our r, we do the Pythagorean theorem. We'd say negative 1 squared plus 0 squared equals r squared equals negative 1 squared plus 0 squared is going to be 1. So our r value is also 1. That was pretty simple. So if we want to find our 6 trigonometric functions, sine of 180, the cosecant of 180, remember those are just going to be reciprocals of each other, cosine of 180, and secant of 180, as well our tangent of 180 and our cotangent of 180. These are the trig functions we are looking for. Now again, if we go back to that table, sine is y over r. Our y value is 0. So 0 over r is 1. So our sine is actually just 0, in which case the cosecant would be the reciprocal of this, so it would be 1 over 0. 1 over 0, similarly to our unit circle finding a tangent, 1 over 0 is undefined. So we'd have to write undefined here. Cosine of 180, remember, was x over r, so we would have our x value was negative 1 over 1, so it's just negative 1. Similarly, secant of 180 would be that positive 1 over negative 1, so it's still just negative 1. Not too difficult to get. The tangent, remember, is going to be our y over x. If y was 0 and x is negative 1, our tangent is 0. The cotangent, remember, is the reciprocal, so we'd have negative 1 over 0, in which case we'd say that that's undefined again. So these would be our 6 trigonometric functions of theta, that is 180 degrees.